Hi everyone, welcome to the video on confidence intervals. This really is one of the last couple of videos that I'm going to be doing for the entire course, so it's a little bit exciting. So a couple of things to go over as we get into this one. Okay, if we have a sample, then the average mu is going to be given just as the sample or population proportion p. And also sigma is going to be given by all this mess just here, so that's a little bit nasty there. But it's really just subbing in this value and n, where n is going to be the number of people in the sample or in the population. To calculate a 95% confidence interval, we need to use this rule here. So you can see I've used the brackets for the confidence interval, and it's just p hat minus 1.96 times the standard deviation. So what this is the average minus 1.96 times the standard deviation, and the average plus 1.96 times the standard deviation. Now that's very, very close to something that we have done before. And I've told you before about how we have 95% of our scores lie within 2 standard deviations of the mean. Well, I did also say that it was just an approximation, so I was, telling the truth in some regard. But it's actually more accurately within 1.96 standard deviations of the mean. And I'm going to show you that just now. So I'm just going to go to interactive and inverse normal CDF. I want the tail setting to be center with a probability of 0.95. And I'm just going to leave sigma and mu as they are. And it comes out to be negative 1.96. Now remember, this, because it's centered, is just giving the left hand end of the interval. So it's pretty close to 2 standard deviations, but it's really just 1.96. So that's where we get this number 1.96 here, and I'm going to suggest that that's a good one just to know. So for a 95% confidence interval, we use 1.96. The margin of error is another thing we need to calculate, and you can see here we call it m, and it's just given by 1.96 times the standard deviation. So it's really just this part of the confidence interval, and again, that's a fairly standard sort of calculation to do, but it's really just the difference between the mean and the end point of the interval. So that is the margin of error. So find a 95% confidence interval when a sample of 150 students is taken and it is found that 90 of them regularly buy lunch at the school canteen. Well, I'm going to start off by finding p hat, and that is 90 of the students buying lunch out of the 150 in total. So that's equal to 0.6. Next, I'm going to set up my confidence interval. So I'll just write the 95% CI is equal to, I'm not going to go writing down the whole rule, I'm just going to write in the number. So it's p hat, which is 0.6, minus the square root of p hat, which again is 0.6, multiplied by 1 minus p hat, which will be 0.4, divided by n, which is the number in the sample here, which is 150. So that's the first value, and the second value is going to be 0.6 plus the square root of 0.6 times 0.4 over 150. And, well, I can go to the calculator and figure that out. So I'll, actually, just give me a moment. Righto, now I have just forgotten one little thing here, and that is actually to write in the 1.96 there and the 1.96 over here as well. Really important that we don't forget that. Now, what I've done, just while I had that pause, was I've gone in here and I've just written in the equation. So I've just typed it in, and if I hit execute, we get 0.5216. That's the lower end of the interval. 0.5216, and the upper end of it, I'll just change that there to a plus rather than typing it all in again, 0.6784. And that's the 95% confidence interval. Now, I will explain that in a little bit of detail. It doesn't mean that 95% of scores are within that interval. What it means is that 95% of the intervals that we create using a sample will have this particular sample proportion in it. Anyway, see you next video.